This is the second question in the FRQ4 packet. Let's get started. We're going to rewrite the function g of x as an expression in the form e raised to a quantity where a and b are constants. Now, as a quick reminder, there is no limitation in terms of what this value is. So this value could be positive, negative, or equal to 0. All right, let's get started. So I have g of x is equal to, and I'm going to start by, I recognize that a power raised to a power, I'm going to multiply. So 10 raised to x times e to the x plus 3 all over e to the 4th. Okay, next up, when I have the same base I'm multiplying, I'm going to go ahead and I'm going to add, when I am multiplying the same base, I'm going to add the exponents. Alright, so adding these and combining like terms, I get 11x plus 3 all over e to the 4th. When you have the same base and you are dividing, you're going to subtract the exponents. And now I'm just going to continue to combine like terms. So I have e to the 11th, 3 subtract 4 is a negative 1. Again, do not circle your results. We want the AP reader to see the progression of this problem. Let's go on to the second part. For the second part of A, we're going to rewrite the function h of x as an expression involving tangent and no other trig functions. So there are 3 Pythagorean identities in trig, and I recognize that this is very similar to secant squared x minus tangent squared x equals 1. So I want to rewrite it in equivalent form. Notice 1 subtracts secant squared. So I'm going to subtract secant squared to both the left and right. It's important that the AP reader sees all of our work. So I have negative tangent squared x equals 1 minus secant squared. So in this position, I'm going to rewrite h of x, and I want, again, the AP reader to not question my thought process in how I'm simplifying this. Now I'm going to replace, give me 1 second to check the work of a student. Okay, thank you for your patience here. So I'm going to replace 1 subtract secant squared with negative tangent squared x. Now when you have the same base, think of this really as a negative 1. There's 2 groups of tangent, that's what tangent squared is. And then we have the tangent in the back. So here I have h of x equals negative 1 times tangent cubed x. I believe you could write it like that. Make sure that 3 is up above. I'm going to make it a little bit neater to make sure there's no confusion. And this is my final result for the second. Let's go move on here to part B. As a reminder, when we look at logs, the base and the value behind the base, these two values must always be greater than 0. And so we're going to check that for extraneous solutions after solving this. We're going to replace, and I want to show all of my work so the AP reader has no question as to what I am doing. So I'm going to start by condensing this. I have the same log base 2. Addition turns into multiplying. X plus 5 times x minus 2. And now when I rewrite this in exponential form, we're going to take, so I'm just going to give you a quick example here. If I had log base a, b equals c, we would take a, raise it to the value on the opposite side, and set it equal to the value behind. In doing that, we're going to take 2, raise it to the value on the opposite side, and set it to what's behind. Now I'm going to go ahead and FOIL this. X squared plus 5x minus 2x minus 10. And when I combine like terms, I have x squared plus 3x minus 10. Now 2 to the third, 2 times 2 times 2 is 8. Remember, you must show every step in order to receive your credit here. Now let's go ahead and let's factor this. And multiplies to give us 18 and combines to give us 3. positive 6 and negative 3 are able to achieve that. So I have x plus 6 and x minus 3. I'm going to take each of these quantities and I'm going to set them equal to 0 and solve. Remember to show all of your steps. So I have negative 6 is equal to x, and I have positive 3 is equal to x. Now don't assume just because it's negative or it's positive, will it be a solution for this equation, or would it be an extraneous solution? Now we're going to take each one of the values and plug it in. Now negative 6 plus 5 would result in a negative 1. We know we need to have a positive here. So this is an extraneous solution. If I plug in 3 plus 5 is positive, 3 minus 2. So I'm not going to circle this because it would negate all of the work, but the only answer is x equals 3. Okay, we're on the second part of B now. Notice that I'm going to look for the values of x in the interval. We include 0 all the way up to, but not including 2 pi. So we're going to take k of x is equal to 0, and now I'm going to replace k of x with 0. Notice that both the left and right contain a sign, so I'm going to factor out a sine of x, and I'd be left with 2 cosine of x plus 1. Now let's make sure I did this right. If I distribute, I get that. If I distribute, no. Each one of these, think of these as a branch left and branch right. I'm going to set equal to 0 at this time, and I'm going to solve. So where is the sign equal to 0? Going around the answer for one time, we can see that the sign is equal to 0, like the y value, both at 0 and at pi. So x would be 0 pi, which is the same as 0, and x would be 1 pi. Okay, let's come over here. Let's subtract 1 from both sides. So I have 2 cosine x equals negative 1, dividing by 2. I have the cosine of x is equal to negative 1/2. So where is the cosine equal to a negative 1/2? So 1, 2, 3. So cosine is the first, so it would be right up here and down here. So 2 pi over 3 and 4 pi over 3. So x equals 2 pi over 3 and x equals 4 pi over 3. So I have 4 different solutions, and all of those solutions are within this interval. So those are my 4 answers for the second part of B. All right, let's get started with part C here. So I want to know, when does m of x yield an output value of negative 3? So I'm going to substitute in negative 3, and I have the ln of 2x squared minus 4 ln of 2x. Now, keep in mind right now that I have people that are coming up here to check their work in class, so I'm going to have to press pause periodically. Okay, thanks for your patience. Here's what I noticed. Notice how these are exactly the same. They're exactly the same. I'm going to do something called u substitution. So I'm going to come off to the side, and I'm going to say u is equal to the ln of 2x. And now let me rewrite this. So I have negative 3 equals, we're going to substitute in temporarily a u. So u squared minus 4u. Okay, so now we're going to add 3 to the opposite side. We have nothing left on the left, and I have u squared minus 4u. Oh, I got to make that a 4u plus 3. Okay, let's factor and solve here for u, and then we'll come back to this problem knowing that u is really equal to the natural log of 2x. So what multiplied is equal positive 3 and combined is equal to negative 4. That'd be negative 3 and negative 1. So I have u minus 3 and u minus 1. I'm going to set each quantity equal to 0 to solve. So plus 3, plus 3, plus 1, plus 1. So I think u equals 3 and u equals 1. I'm going to come up here so that you guys can continue to see my work here. This is what I know. I know that u is equal to the ln of 2x. So I'm going to start with 3. So I'm going to substitute in 3 for this quantity. So u equals 3 and u equals 1. So let's try 3. 3 equals the ln of 2x. x. Well, another way to represent ln is log base 3, or log base e. So log base e of 2x. Remember, we can write this in exponential form. It's base raised to the value on the opposite side of the equal sign equals, in this case, 2x. And then now to isolate the x, I'm going to divide by 2 and divide by 2. So e raised to the third divided by 2 equals x. Remember that the value behind any log needs to be positive, and we have a positive value raised to the third divided by 2 is still going to be a positive, so it's not going to impact the domain. So this is one answer. Make sure not to circle it. The results, let's go on to the next one. Maybe we do an arrow so everybody can see, but we're not going to circle it. And now I'm going to do the exact same thing with 1. So I have u equals 1. So 1 equals the ln of 2x. I'm going to rewrite the ln as log base e of 2x equals 1. And now write it in exponential form. In exponential form, it's e raised to the first equals 2x dividing by 2. I get e to the first divided by 2 equals x. And here is my second answer.